All right, here's example number 2. In this case, they've given you the desired equation. You've already got it. You've got 2 reactions, 2 known reactions in your reference table that we're going to build this. That's where we're going to start from. So underneath this, I just start plugging away one piece at a time. I want lead sulfide. So the only one with lead sulfide is reaction A, and it's the right number, and it's on the right side. What I want. So I just leave it. Leave A completely alone. Write it down. Lead solid plus 3 halves O2 comes lead oxide plus, left it alone, so the delta H is negative 430. Now, in this case, one reaction has checked off a couple of boxes for me. I have my lead solid, it's my lead sulfide there. I also have my 3 halves oxygen right there, and I have my sulfur dioxide. So in this case, that one reaction has checked off a bunch of boxes for me. Rather, you don't have to do a separate reaction for each one. Can do. Okay. So now the next thing I need is carbon. That's in reaction B, and you'll notice it's also on the reactant side where I want it, and it's the right number. So I can leave that one alone. Leave B. That gives me oxide, carbon, lead, plus carbon monoxide, delta H positive 1. All right, and this one I've checked off my carbon, I check off my lead right here, and I check off my carbon monoxide. So at this point, I have found all the pieces that I need to make the desired equation. They're all here. All I need to do now is make sure I'm not left with any leftover bits. And in this case, I'm not, because the lead oxide here, lead oxide, they're gone. So now the net equation I'm left with is exactly my desired. And since that's the case, I can take these delta H values and we can add them. Negative 7 plus 106.8 for a delta H. Write it down here so I have a little more room. Actually, I'll write it over here so you guys. 306.9. Go back to the question. Make sure that I'm getting, because remember that's a delta H value. And in this case, it just says, what is the enthalpy change for the following chemical reaction? It doesn't say molar, it just says enthalpy change. So delta H is what I wanted. That's my good to go. All right, one more. On this one, what is the molar heat of combustion of methane? So methane is CH4. I'm combusting it, so I know I need oxygen. And we'll assume complete combustion. So I know I've got carbon dioxide and water vapor on this side. Don't know that delta. So there's my desired equation. We've got 3 reactions they've given us in our table this time. So let's start with methane. CH4 is in reaction B, but it's on the wrong side. So I got to reverse reaction B. That's going to give me a 4 comes carbon plus 2. Delta H is now a positive 74.6. So I can go through and I can check, and nothing else so far. So now we move on to the next thing in the list, which in this case is oxygen. Oxygen is in reaction A and reaction C. I don't know which one to use, so I'm going to skip it. Most times if you skip something that's in more than one reaction, it'll work itself out in the end. So let's move on to carbon dioxide, which is in reaction A. on the right side, it's on the product side like I want, and it's the right number. So I can, oh, you know what? Pause. I skipped a very important step. I didn't balance this. Carbon, carbon. Now we're good. All right. So I can leave A. So I've got carbon plus O2 coming. Oh, no, not balanced. Now I'm good. Becoming CO2 on the other side, and I left it, so delta H negative 390. All right, that gives me my carbon dioxide. It gives me one oxygen, but not two, so I'm going to leave that for now because I don't have everything. Still don't have water. So I go back to the reference table now. I need 2 water gas. Be very careful with water. Water gas and water liquid are one of the ones that will show up in 2 different states, and they have different. Careful with it. So I want water vapor, which is in C. It's on the right side. It's on the product side, but it's not the right number. It only has 1. I need. So I'm going to take reaction C and double it. So that's going to give 2 H2s plus half O2 doubled is just an O2. And then 2. So that means I've got a delta H of negative 480. Not even going to check that one. All right. So now I go through. I've got my 2 water. Check. Let's see if the oxygen worked out. I needed 2 oxygen. Boom. If I combine those together, I've got my 2 oxygen. Now I can check that off. But I've got some leftovers that I need to make sure cancel out. Carbon here, here, 2 hydrogens here, 2 hydrogens there. Boom, got it. So everything that we're left with is our desired equation. So I can take these delta H values and add them up. 74.6 minus 393.5 and minus 486. I get a delta H negative 802.5 kilojoules. This question says, what's the molar heat of combustion? 802.5. It wants the molar heat of combustion, not just combustion. Not just, sorry, enthalpy, molar, or molar enthalpy. So I need to change this to the number of moles. Now I know this isn't going to change the number, but I want you to get in this habit. This number that we just calculated is a delta H. I need a delta H. So I have to take negative 802.5 kilojoules divided by 1 mole of CH4. I end up with a delta HM of negative 802. That's my. So even though in this case the numerical value didn't change, it's still 802.5. Get in that habit of just always making sure you remember Hess's law gives me delta H. I have to divide by moles to get the delta H. Be safe. Don't mess that up. Just get into that habit right off the bat. So that's the key. Start with a balanced equation. Start with a desired equation. Don't like I did on example 2. An equation. Make sure it's balanced. Make sure it's balanced. And then go through one piece at a time, building out of the puzzle piece of that desired equation. If you end up with exactly your desired equation, did it perfect. Add up those delta H's, your answer. Then at the end, just make sure you check, is this asking me for enthalpy or is this asking me? Okay, so in your notes, in the questions, you've got one other table. Let me show you this quick. The first thing you've got in your notes is this table like this. And it's got a whole bunch of different reactions that are given to you. Some of the questions in your homework are going to say, here's a reference table, just like these examples did. But you can also use any equations from that page. So you could use maybe, like if it was a question like this, maybe you used A and B, then you also used 13 from this table. So just the questions will specify if that's fair game for you. But otherwise, that's it. It's basically puzzle building. I like this kind of stuff because, like I said, it's not big formulas or anything like that. It's just trying to build it like a puzzle out. Hopefully you enjoy it at least a little bit. That's Hess's law, and good luck. If you have any trouble, let me know.